I'm going to start here with one quick caution as far as modeling goes, that everyone who's taken stats should have at least heard, and even if you have heard this before, it's still worth being reiterated, and that is that outside of really finessed situations, it's incredibly rare to have data that perfectly fits to an exact pattern in just the right way that you want it. Usually if that does occur, you kind of have to wonder whether something went wrong, or if you are lying to yourself to try and make things look better, because it's almost never going to be absolutely perfect, but there are some patterns that datasets will naturally fall into, or at least close to. Things like exponential growth patterns, or decay patterns, or different logarithmic patterns, linear patterns, and then tons and tons and tons of other data patterns that you can see in terms of simple and more advanced statistical modeling that if you go far with stats you will see a few of. We're going to talk a little bit about some of the ones that we have right here though in terms of the things that we've seen to this point, but know that there's a lot more going on here than just have nice picture, see nice thing. It's worth being aware of, it's worth getting some sense of here at least though. So let's take an example talking about how this sort of thing can run. So for this we have that the given table and scatter plot show the populations of various cities in thousands and the average walking speed in feet per second of a person living in the city, where we've got that data set, we've got our scatter plot, and we want to think for ourselves what kind of function would be a good fit for modeling this data. So essentially what we're doing here is looking at that pattern and trying to see if we have a pattern that could map nicely onto it. And in this case, again, it's not perfect, but that does seem like it's got that little upward trending and then sloping off curve that seems like a good fit for a logarithmic model. Now, from there, the real question isn't so much seeing that that's a logarithmic model as it is being able to accurately define that model. And that's more of an advanced statistics question, to be able to understand how you set an equation to fit a data pattern. And then for that matter, we've only got 5 data points here. It might be that if you took 5 more, it would completely ruin that pattern. You want to use something else. So in practice, there's both a lot more work to go on in terms of how you set your pattern properly, how you properly define a function to describe what's going on there, and then also you'd want to do a lot more data collection than just 5 things, because a sample size that small is leaving yourself really wide open to have just collected a little bit of noise instead of meaningful data. But those are questions for a statistician. Right now we're just getting a sense of how this type of thing can be used in practice. Anyway, we're going to finish this chapter properly, we're going to finish this section properly by talking one more time about how we can get things in terms of our, hopefully, very favorite number, E.